Welcome to this video lecture on the subject electronic circuits. So in this lecture we are going to discuss about bistable multivibrator. So bistable multivibrator is a two-state device. So it consists of two stable states in which one of the state is on and another is off. So when trigger pulse is required to switch the circuit back to its original state. So trigger pulse applied to the circuit causes it to switch from one state to other state. So it consists of two stable states. So it is also referred as flip-flops because it is used to store the binary information and also it is used to generate the pulse waveform. So here the circuit of the bistable multivibrator is shown in which the two transistors Q1, Q2 are used and Q1 base is connected to R2 and similarly Q2 base is connected to R1. So this circuit, the output of the transistor is coupled to base of the transistor. So when we are applying an external trigger pulse to this circuit, transition occurs from one state to other state. For example, consider when the circuit is first switched on from VCC, one of the transistors will start conducting more than the other. So for example, transistor is Q1 is on means Q2 is off. So because of the regenerative feedback action, the other transistor is taken into cutoff state. So let's assume that transistor Q1 is on. So initially only one transistor is on, so the Q2 is off. So this state is the stable state. So in case of bistable multivibrator, we need to apply an external trigger pulse from the outside. So positive triggering pulse applied to the reset input. So reset input means second transistor of base. So it increases the forward bias. So therefore the second transistor Q2 becomes on. So this will increase the collector current and decrease the collector voltage. So the fall in collector voltage is coupled to base of transistor Q1 since it is connected to the base of Q1. So it reverse biases the base emitter circuit and Q1 is turned off. So like this trigger pulse changes the transistor state from Q1 on condition to Q1 off. So now what happens is the second transistor Q2 becomes on in this state. So the circuit is then in its second stable state. So and remains so till a positive trigger pulse is applied. So we have already discussed that stable state of bistable multivibrator will be remained as such. So until we are applying a external trigger pulse. So similar action can be achieved by applying a negative pulse at the set input. So we have two transistors, one is Q1 and Q2. So set input is applied at the base of the Q1. So the same condition happens because of the external triggering pulse. So it changes the transition from first stable state to the second stable state, and by applying the negative pulse at the reset input, reverse transition can be obtained. So like this stable state and one stable state to another stable state is changed. And what are the applications of bistable? So the bistable multivibrator is used as memory element in shift registers, counters and so on. Since it has two stable state, it can be operated as flip-flop in digital circuit, and it is used to generate the square wave of symmetrical shape. So it is used as a square wave generator and by sending regular triggering pulse to the input signal. So by adjusting the frequency of the input trigger pulse, the width of the square wave can be altered. So the square wave width this depends on the triggering pulse we are applied. So the frequency of the triggering pulse determines the width of the output wave. So it is also used as a frequency divider. For example, divide by 2 counter. So these are the various applications of bistable multivibrator in digital circuits. Let's take the assessment question. How many stable state does a bistable multivibrator have? So as we discussed, it consists of two stable state. And what is required to change the state of a bistable multivibrator? So the answer is external trigger pulse. So thank you for listening this lecture.